Okay, now we're going to solve inequalities by subtraction, because subtraction can also be used to solve inequalities just like we used it to solve equations. So if you subtract the same number from an inequality, if it's greater than, less than, greater than or equal to, less than or equal to, the resulting inequality still holds true. Okay, so we can solve inequalities like m plus 19 is greater than 56. So you have the original inequality, subtract 19 from both sides to get m by itself, and you have m is greater than 37. And in set builder notation, it would be you put a bracket, the variable, a slash, and then the inequality, and then close with the other bracket, or the brace rather. And you would read that the set of all m such that, the little line, vertical line, you would read as such that m is greater than 37. If we were to graph it on a number line, you would just put 37, an open circle because it's strictly greater than, it's not or equal to, and then shade everything to the right. Okay? Here's one for you to try. Go ahead and solve p plus 8 is less than or equal to 18, and graph it too, just so you can see if you graph it correctly. Go ahead and pause the video. Okay, we're back. So if you subtract 8 from both sides, you get p is less than or equal to 10. And the solution would be the set of all p such that p is less than or equal to 10. And on the number line, 10 is the boundary point, so you put a circle and shade the circle in. And then everything less than it, so that way. Pretty cool, huh? Terms that are constants are not the only terms that can be subtracted. Terms with variables can also be subtracted from each side to solve inequality. So, and you can do this with addition. If you have 3a plus 6 is less than or equal to 4a, we want to solve that and then graph the solution. So you have the original inequality. And remember, when we solved equations, we got all the terms, the variables on the one side and the constants on the other side. So here what we're going to do is the 6 is already on this side, so if I would leave the 6 there and get the a's on the other side, I'd have to subtract 3a from both sides, and you get 6 is less than or equal to a, which means that 6 is less than or equal to the numbers, which means that that's the same as a is greater than or equal to 6. So the solution set is all a such that a is greater than or equal to 6. You put a shaded closed dot on 6 and shade everything above it. All right. So here's 2 for you to try. Go ahead and pause the video. Make sure you graph these. Okay, we're back. So for 3a, you subtract 9n from both sides. Be careful with this one because the 1 is negative, not the 9n. So maybe you added 9n to both sides, or maybe you forgot the negative on the 1. Make sure you don't do that. The 9 is positive, so to get rid of it, do the opposite. So subtract 9, and you would get negative 1 is less than 1n. And if you had the 1 there, you could divide it off, which would just give you n and negative 1. So negative 1 is less than n. That's the same as n is greater than negative 1. So in set builder notation, it'd be the set of all n such that n is greater than negative 1. And if you graph it on a number line, here's negative 1. Open circle on the 1 and shade everything to the right. For 3b, I would subtract 4h from both sides. You get h is less than or equal to 12. So the solution is the set of all h such that h is less than or equal to 12. On the number line, you put 12, close circle because it's or equal to, and h is less than 12, so shade everything to the left. Pretty cool, huh? All right, variable problems containing phrases like greater than or less than can be solved using inequalities, and this chart shows some other phrases that indicate inequalities. Less than or fewer than, greater than or more than, at most, no more than, less than or equal to means less than or equal to. And if you have greater than or equal to, that phrase means greater than or equal to, but at least or no less than. So for example, if I say I want to go to at least 5 birthday parties this year. That'd be 5 or more. Okay, it would be greater than or equal to 5. So here's an example. Felipe needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. Currently, the basking spot is 62.5. How much warmer does the basking spot need to be? So the current temperature needs to be at least 82 degrees. So let T be the number of degrees that the temperature needs to rise. So it's 62.5 degrees already. We need to add some more degrees so that it's at least 82 degrees. So 62.5 plus T is greater than or equal to 82. So I solve that by subtracting 65 from both sides. And then I would have T is greater than or equal to 19.5. So that means that Felipe needs to raise the temperature of the basking spot 19.5 or more degrees. So here's one for you to try. Go ahead and read it and pause the video and hit play when you're ready. All right, so Sanjay has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. Sanjay wants a pair of jeans. How much can he spend? So if I have $18 plus $14 plus some amount of money, that has to be less than or equal to 65 because he can spend at most $65. Okay? So the 18 plus 14 is 32 plus D is less than or equal to 65. So subtract 32. D is less than or equal to 33. So he can spend at most $33. So the pair of jeans has to be $33 or less. All right, guys, that's it for this section. Continue on to your assignment. And as always, reach out to me if you have any questions. Take care.